right, today we're going to be doing an experiment involving pennies and oxidation reactions with them, or rusting is what it would look like to the common eye. So rust is a chemical reaction involving the exchange between electrons, and rust is actually used to describe when oxidation happens to iron, not to copper, but to the common eye it would appear that it is rust, common knowledge. So the metal loses electrons and creates ions, and that's in a rusting process. So in this experiment with taking the pennies and placing them in the solution of vinegar and salt, those are acting as catalysts for us. So salt and acid increase the conductivity of moisture around the metal, making it rust more quickly. The faster the electrons can flow more freely, the quicker it can oxidize or rust. So with the catalyst opening up those doors of making these electrons more available, and as we learned, rust is a chemical reaction, or the exchange of electrons between atoms. If a catalyst is making those electrons more available, then the process is going to happen much more quickly. So certain catalysts can increase the electrical activity between iron and oxygen, and that would be rust, or in this case, between copper and oxygen, and it speeds up the process. So in this experiment with taking the pennies, putting them in the salt and the vinegar mixture, those are acting as our catalysts and making it conduct the oxidation much more quickly. Like we discussed with the pennies, it's not actual rust, but it's a similar concept of losing electrons and oxygen mixing with the oxygen that's in the air and making the copper oxidize. So we say rust, but it's actually oxidizing. It's not actually rusting, which that's just pertinent to iron. So the color change that we are going to see, or what we hoped to see, which you can only see very closely, is a greenish tarnish that we see, and it's called malachite. To make rust. Oops. So the salt and vinegar, when we put the pennies in, causes corrosion of this top copper layer, and it allows the copper atoms to be more available to join oxygen atoms from the air, which is oxidation. So the copper atoms electrons are more available, oxygen more available. When those form, it causes or creates copper oxide, which is what we result from the oxidation reaction. So the positive hydrogen plus ions that are in the vinegar or acetic acid are going to take electrons from the copper, making it more available to be oxidized. So a fun little fact that I found was that the Statue of Liberty, with the greenish bluish tarnish color, was covered in a layer of copper, and with all the rain and water that's constantly on it, it's almost acting as a catalyst. It's acting as the medium, making those electrons more available, and so it actually is doing the same thing. It's creating that malachite tarnish when it's reacting with the oxygen. So other fun fact that I learned that explains a little bit why my experiment didn't go quite as well as the demonstration video is that pennies that were made prior to 1982 were made of solid copper, whereas after 1982 they were copper and zinc, which means that they're going to react less in the way that we're predicting. So I'll go through and I'll show my pennies, but I could not find any that were prior to 1982. So they did not tarnish as much as we anticipated, but we'll still show. So this is the first penny. This is prior. This is how dirty it was. There's a little part at the top of the head where I'm pointing that I dropped just a little bit of the salt and vinegar solution on it, let it sit for 20 minutes, and then washed it off. So it kind of started to shine that area up, but that shows how dirty it was prior. All right, this next penny is after it was washed and shined in the salt and vinegar mixture and then washed off with water. Washing it off with water is taking those catalysts away and almost neutralizing it. So it looks like it kept the shine with no tarnish. All right, and these next two, I didn't know how well this was gonna work. So the next two started off like this one that looked really shiny. but I did not wash off the salt and vinegar. So as you can see, there's a little bit of tarnish on there. Same with this one. Didn't quite get a full coverage, but like we learned from our fun fact, since they are not made of pure copper, that might be why they reacted less, and we did not get the experiment that we were quite predicting. So overall, I think we got a good experiment. It did work, and it showed just kind of how quickly those work. I mean, these have been sitting for 2 days, but the full tarnish and cleanse and everything really appeared after about an hour. And so it just really shows how quickly those things react, and how we're, adding a catalyst into this, and it's speeding up the reaction with the vinegar and the salt. So overall, I think the experiment worked, and I think it showed a really good oxidation reaction, or rusting as it appeared. And it was a successful experiment. Thanks.